So in the unit, we are talking about in transforms and partial differential equations. In third unit, we are talking about classification of second order linear PDE. So in this, we'll just be talking about two topics: method of separation of variables and classification of second order linear partial differential equations. So first one is boundary value problems. So what is boundary value problems? So in science and engineering, we'll always seek a solution for differential equations with some specified conditions. Okay, for that specific condition, we'll be giving and that specific condition will be knowing as boundary conditions. Okay, and the differential equation together with this boundary condition constitutes a boundary value problem. Okay, the specific condition is boundary condition, and the differential equation with the specific boundary condition is the boundary value problems. Okay, so in this you'll be talking about the boundary value problem. Method of separation of variables. So this is the topic we are talking about. So most of the boundary value problems will be in linear partial differential equations. Okay, and it will be most probably solved by using method of separation of variables. Okay, so what is method of separation of variables is that you will be separating the equation. Let it be u is equal to xy. Okay, so where u is your dependent variable and x and y will be your independent variables, because u is dependent on x and y. Okay, now I'll be splitting this x as one equation and y to the other side, equating x to one of the constant and y to one of the constant. I'll be solving these x and y equations separately. Then I'll be writing it in the form of z is equal to xy. Okay, so capital X into capital Y. For capital X, it is a function of small x alone. There will be no y or other terms. And for capital Y, it is a function of small y alone. Okay, so and the particular solutions of this differential equation will be given in the form of physical problems also. Okay, so you just have to know that to solve the method of separation of variables for any z is equal to x, y, x is a function of small x and y is a function of small y, you will constitute this two separately and equate it to the constant, and you will find the answer. Okay, you will get you see here y double dash by y is equal to a thing I'm taking here. First one, it becomes m square minus 2m minus a equal to 0. So it is of the form quadratic equation formula minus b plus or minus root of b square minus 4ac divided by a, or you can solve the equation. You will get 1 plus or minus root 1 plus a. So on writing it in auxiliary equation form, c1 e power 1 plus root of 1 plus ax plus c2 into e of 1 minus root 1 plus ax. To solve y dash plus ay equal to 0, so y dash plus y is equal to minus a. So on solving this, you will get y is equal to c3 e power minus ay. So you will get the required solution for z equal to xy. Okay, now problem 2, this you have to work out on your own. I'm just giving the hint alone. Dou u by dou x equal to 2 into dou u by dou t equal to plus u, where u x comma 0 is equal to 6 e power minus x. It is of the form x and t, not of the form x and y. So instead of y, you will be using t. Okay, so first find dou u by dou x, then dou u by dou t, substitute in the equation, put all the x dash form terms in one side and t dash forms in one side, equate it to the constant. Solve the first equation, then solve the second equation, and you will get the final answer. U is equal to ae 1 plus 2k into x plus kt, and you know that u of x comma 0 is equal to 6 e power minus 3x. So on comparing these two things, I'll get a is equal to 6, then minus 3 is equal to 1 plus 2k into x plus kt. So minus 3x instead of 1 plus 2k. So 1 plus 2k is equal to minus 3, k is equal to minus 2. Okay, so substitute the values and you will get u as a solution. The extra thing is that you have to compare both u equations. That's it. Okay, now this is for your homework. Do this sum the like same wise the above sum. This is the homework for you. Do this problem and check it out whether you could solve all these problems. This is the final answer. Now ux equal to 4uy. Okay, u is nothing but dou u divided by dou x, uy is dou u divided by dou y. Okay, and is of the form x dash y equal to 4xy dash. Okay, so ux plus 4uy. Now we have to differentiate with respect to 2x and differentiate with respect to 2y. Substitute it in the equation, equate it to the constant k, solve x, you will get c1 e kx, solve y, you will get c2 e ky divided by 4, and you have to compare 2, you will get c e power k into x plus y power 4. Comparing with 8 e minus 3y, you will get c is equal to 8. Okay, for k it is nothing but k y plus 4, kx plus ky plus 4. Y is the term you are talking here, so ky by 4 is equal to minus 3y, so k is equal to minus 12. Okay, substitute it and find the final answer. Classification of second order linear partial differential equations. So a u plus b u x y plus c u y y plus d u x plus e u y plus f of u is equal to f of x comma y. And you know that there is a condition for real ellipse, parabola and hyperbola, b square minus 5 4ac. So you will be given a question. In that question, find the value of, from that find the value of b, a, c, d, e, f. If you find b square minus 4ac, if it is less than 0, it is elliptic, equal to 0, parabolic, greater than 0, it is hyperbolic. That's it. And this sum you could easily find it. If it is of elliptic type, it is of the formula uxx plus uyy equal to 0, which is a Laplace equation. Uxx plus uyy equal to f of x comma y. It is a Poisson equation. Dou u by dou t is equal to a square into dou square u divided by dou x square, which is one dimensional heat flow equation. Dou square u divided by dou t square equal to c square into dou square y divided by dou x square, which is one dimensional wave equation. So this is the type, and these are some of the equations. So Laplace equation and Poisson equation are of elliptic type, one dimensional heat flow equation and one dimensional wave equation are of parabolic and hyperbolic type. So first, uxx plus x uyy equal to 0. So from this you could find the value. A is equal to 1, b is equal to 0, c is equal to x. B square minus 4ac, which is minus 4x. If the value of x is greater than 0, okay, if it is 0, the whole becomes 0, so it will be a parabolic equation. If the x is greater than 0, minus into minus it becomes plus, the value will be greater than 0, so it is elliptic. And if you find x is equal to less than 0, it would become, for example, x is minus 1, minus into minus plus becomes 4, which becomes hyperbolic equation. So in this type, if it is 4x, you have to substitute value for x. If it is x is equal to 0, obviously it is parabolic equation. If x is greater than 0, you will get value in the minus, so it is a elliptic equation. If x is less than 0, you will get my answer in the positive term, which will be greater than 0, so it will be hyperbolic. Okay. Next, from second one, you could find the value of a, b, c. Substitute it would become 0, so it is parabolic equation. And it is 1 greater than 0, it becomes hyperbolic equation. And we have to classify the PDE. From this you could write a, b, c, substitute it, solve it, you will get which will be hyperbolic equation. Second one, a value is 4, b value is 4, c value is 4, 0, parabolic equation. 1 to 1, which is a parabolic equation. Dou square f divided by dou x square plus 2 into dou square f divided by dou x dou y. So a is equal to 1, b is equal to 2, c is equal to 4. So b square minus 4ac, which is elliptic. So from here, a is equal to 1, b is equal to 0, c is equal to 1. Okay, so you will get equal to 0. Then for second equation, a is equal to 1, b is equal to 0, c is equal to x square. Find the value, then substitute the values, you will get it is an elliptic equation. That's it. Thank you.